are going to get to be the test class. So 4A.6 is systems in 3 variables elimination method. You should have the half sheet that I gave you. That's going to talk through the steps, but we're going to first talk about types of systems. So we are now working with X, Y, and Z. So we're no longer working with lines. We're working with planes. Okay. If you remember from geometry, 3 points make up a plane. Do y'all remember that somewhere in your geometry lives? And so we are now working with planes. When you have planes, if it occurs where no point lies in all 3 planes, that's a no solution situation. Okay. If they all perfectly intersect at the same point, the point lies on all 3 planes, then there's one solution. And there's an infinite number solution if the planes intersect all at the points along a common line. Okay. A common line means that literally y equals blah, 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 or x equals. It's a 2 variable solution. That's the same for all of them. Okay. So we're going to model or go through how to solve for this. So up first, steps to solve by elimination. So you should have this half sheet. Yes. So you have the half sheets for steps for solving by elimination. And this goes with our 4A.6 notes. Okay. You're going to write all the equations in standard form, cleared of decimals or fractions. So in standard form, it's going to be AX plus BY plus CZ equals D. That's our standard form. Whereas A, B, and C are coefficients and D is a constant. You're going to label your equations. Some people like to label them with shapes. Some people like to label them with numbers. Some people like to label, however you choose to label is up to you. I'll model how I choose to label. Choose a variable to eliminate. Then choose any 2 of the 3 equations and eliminate the chosen variable. Then we're going to select a different set of 2 equations and eliminate the same variable as in the first step, step 3. Then you're going to solve the 2 equations from step 3 and 4 for 2 variables they contain. You're going to then use substitute. And this is where we go back to substitution by 2 variables into the equation and solve for the remaining variables and then check your solution. The steps are like, okay, here are the steps. Until you follow through with the steps, they do not make sense. Why do I say this? Because I remember being a kid and staring at my teacher like, what the heck were you talking about? Okay. The steps do not make sense until you go through with it. So we're going to dive on in. I'm going to move this so you can see the problem. All right, so our first example that I would like for you to write down is we have 2x minus y plus z equals 4. And then we have x plus 3y minus z equals 11. 4x plus y minus z equals 14. Turn on the music. Thank you. That's not good. All right. So when you're eliminating, you want to think about what can I eliminate with the minimum manipulation to the current problem. Okay. What can I eliminate without having to change the current problem that much? Okay. So in this case, it would be our z variable. The reason why I say z is because if you look at z, you have a term that's positive, a term that's negative, and a term that's negative. So without having to do a whole lot of manipulation, I can get rid of z. Does that make sense? So we would want to focus on eliminating z. If you would like to do y, you could as well, but you would have to manipulate by multiplying by 3. Does that make sense? Because the coefficients aren't the same. And if the coefficients aren't the same, absolute value, same, then it's not going to work, right? Because I can't eliminate otherwise. So we're going to focus on eliminating our z's. You got to go. You got to go. You got to go. Okay. So second step says to number your equations. The reason why you number your equations is so that you know which 2 equations you're working with at a time. All right. I know people who number them with stars, hearts, and circles. I know people who number them ABC. I know people who number them 1, 2, 3. How you choose the number is 100% up to you. as long as you understand your numbering system, okay? I'm just going to label them 1, 2, and 3 because it doesn't bother me. Some people get overwhelmed with too many numbers, but I don't. So this is equation 1, this is equation 2, and this is going to be equation 3. Okay, you're going to decide on how you're going to pair the equations off. Okay, so you're going to pair them off so that you can eliminate. My first pair of equations are going to be equation 1 and equation number 2. My second pair of equations is going to be equation number 1 and equation number 3. Because the goal is to eliminate z. So I'm going to rewrite it, just those two equations. So with equation number 1, I have 2x minus y plus z equals 4. Equation number 2, I have x plus 3y minus z equals 11. So I'm combining these two equations. I get 2x plus 1x makes 3x. I have negative 1 plus 3y is 2y. And what happens to my z's? They cancel, which was the plan all along, right? And that equals 15. Okay, my next two equations that I decided I was going to combine in order to eliminate the z are equations 1 and 3. So I'm going to combine equations 1 and 3. So we have 2x minus y plus z equals 4. Then we have 4x plus y minus z equals 14. Going to combine them. I get 2x and 4x make 6x. And look what happens here. Y cancels and z cancels. So I'm left with 18. Now this is a gold mine when that happens. Yes. More than what I needed went away. Okay. So that's what that third step is describing. Can I go back to the steps really quick? So when it says choose a variable to eliminate, then choose any of the three equations and eliminate the chosen variable. Okay. So we did that. We did 3 and 4. We chose our two equations. We eliminated. All right. That's what 3 and 4 means. How do we feel about 3 and 4 now? Doable? Okay. We've chosen. Now we're going to solve the two equations from steps 2 and 3 and 4. So we're going to solve these. This one, you're just going to solve by getting a variable by itself. Does it matter which one I do? No, I'm just going to always go for y because it's just a natural habit to get y by itself, right? So to get y by itself, what do we do? Minus 3x. So we have 15 minus 3x. And then what are we going to have to do? Then divide by 2. On this one, what am I going to have to do to get y by itself? Divide by 6. I mean, x by itself, I'm sorry. And we get x equals 3. So now I'm in a position to start solving. I already found x, right? Boom. Now that I found x, can I find y? So now I can find y. So where x is, we're now replacing it with a 3. So we have y equals 15 minus 3 times 3 divided by 2. What's 15 minus 9? 6. 6 divided by 2 is 3. So now we also know that y equals 3. Okay, once you've now found your x and y, we're on to step 6. We're gonna take those two and you're gonna plug it into either equation in the original to find your remaining variable. Does it matter which one we do? No. So we're just gonna plug it into the original. So in the original, I'm gonna use this one because z is positive, so I won't have to divide by negative. Does that make sense? So I know the value of x and I know the value of y. So we have 2 times 3 minus 3 plus z equals 4. What is 6 minus 3? 3 plus z equals 4. What would z have to be for this to be a true statement? Z would have to equal 1. So then the last step is your solution and then checking your solution. Your solution is always listed as x, comma, y, comma, z. So my solution is 3, comma, 3, comma, 1. And if I wasn't confident, I would take each variable and plug it back in to check myself. So for example, in the first one, I would say, okay, I'm going to plug in 3. I'm going to plug in x equals 3, y equals 3, z equals 1. 2 times 3 is 6 minus 3 is 3 plus 1 is 4. Oh my gosh, it works. Okay. And then I'm like, okay, I feel good about it. I think I got it. I did it. Oh yeah. Okay. So let's recap all of our steps. We're going to label as we recap what we did for each one. I'll have to go back and forth. So step 1 is write all equations in standard form. That's the very first step. Step 1 is to write all equations in standard form. Are they already in standard form? Yes. Step 2 is to label your equations. So I labeled my equations. 1, 2, 3. Step 3 is to choose a variable to eliminate. So we chose our variable to eliminate. Then choose any 2 of the 3 equations. So that's where we chose our variable. And we chose our first equation, which was 1 and 2. Then we chose step 4 is select a different set of 2 equations. So step 4, we selected a different set of equation and also eliminated. Step 5 was to solve for those values. So we solve for y, solve for x. And then step 6 is where we start substituting in our values. So we substitute in here and we substitute in here. This is a continuation of that step. Step 7 is where we find our solution and check our solution. So our solution is 331, and then we did a verbal check out loud on what to do or what we were right. And that's how your steps are going through. So 1, making sure they're in the correct form. 2, labeling. 3, choosing your first pair to eliminate. 4, choosing your second pair to use for elimination. 5 is solving the variables that you have. 6 is going through and starting to find your X, Y, and Z. And 7 is your solution and stating and checking, sorry. All right, so do you see why I would say it's very important and why we spent so much time practicing the algebra? Because there's no way out of the algebra right now. Does that make sense? It's kind of there and we got to figure it out. All right, are we again ready for another example? We're going to go to example 2. Take a moment, write it down. So for example 2, you have x minus y plus z equals -1. Then you have x plus y plus 3z equals -3. And then you have 2x minus y plus 2z equals 0. Right? If you feel confident that you see what to do, you can work ahead. Otherwise, you can follow along with me. Okay. So step 1 says to make sure that we are in standard form. Are we in standard form? Yes, check on that. Step 2 is to label. So I have equation 1, equation 2, and equation 3. Step 2 is done. Step 3 is to choose a variable that you're going to eliminate and go from there. What variable do you think we should eliminate? Y. Good job. The variable we're going to eliminate is Y. So we're going to choose our first equations, our first pair of equations to eliminate. So which two should I start with? 1 and 2. Good place. So we're going to use equations 1 and 2. So that gives us x minus y plus z equals -1. And we have x plus y plus 3z equals -3. For elimination, that means you're combining, correct? So we have 1x and 1x makes 2x. Did our y's eliminate already, naturally? Yes. We have 1z and 3z, and that makes 4z. And it equals -4. Okay? Step 4 is to choose another pair of equations to eliminate that variable with. Which other pair of equation are we going to use? 2 and 3. Good job. So we chose 2 and 3. So we have x plus y plus 3z equals -3. Then we have 2x minus y plus 2z equals 0. We're going to combine them. 1x plus 2x equals 3x. Our y's are doing what they're supposed to, and they are eliminated. We then have 3z plus 2z, which makes 5z. And we get -3, and 0 makes -3. Okay. Step 5, it says to use substitution to solve for those two variables, right? On step 5, we didn't get lucky this time to get down to 1. So on step 5, we just need to solve one variable, substitute it in, solve for the other. Regular substitution, right? Okay, it doesn't matter which one, but you usually want to try to use the one that's going to have friendlier numbers to work with, right? So between working with 2 and 4 and 3 and 5, which is more friendly? 2 and 4.
There's no one in the restroom, no one in the hallway. You need to remain in your class at this time. But in the hallway, make your way to the class at this time. We're on a hold. Thank you.
Every day. Keep us on our toes, guys. Keep us on our toes. Okay. Yeah. All right, Cooper Wing is good. You know, keep your head on a swivel, guys. Keep your head on a swivel. All right, so we said 2 and 4, right? So getting one of these by themselves. So let's get x by itself. Yeah, let's do x. Because therefore we won't have to have a fraction. Because if we get z by itself, we're going to be stuck divided by 4, right? And we don't want that. So let's get x by itself. What are the steps to get x by itself? Subtract the 4z. So first step is going to be x equals -4 minus 4z. Then what's the next thing to do? Divide everything by 2. So now we have x equals -2 minus 2z. Okay, so this is where like our pattern recognition, our number sense come into play. Like how smart can I be with my numbers to make my life easier? Honestly, it takes time. All right, so now I have something that I can substitute in. I don't have a number, but I do have a replacement for x, correct? So I'm going to replace. So where x is, it now becomes -2 minus 2z plus 5z equals -3. Oh my gosh, does that look familiar to what we've been doing? Crazy. That's so crazy. Who knew we were going to lead up to this? All right. So when we get to this point, we do our trifecta. We distribute, combine, and isolate the variable, DCI. Distribute, combine, isolate the variable. Distribute, combine, isolate the variable. All right. So we're going to distribute. 3 times -2 is -6. So we get -6z plus 5z equals -3. And then after we distribute, what's the next thing? Combine. So we have -6z and positive 5z, and that makes -z. All right. Now we're at the isolate the variable. What do I need to do to isolate the variable? There we go. I'm going to add 6 to both sides and then do what? Divide by what? Negative. Divide by -1. So z equals, what's -3 plus 6? 3, and 3 divided by -1 is -3. So we now have that z equals -3. Okay, now we're at step 6 where we just start plugging things in and working our way back, right? Because we have a value. So step 5, thanks. Now step 6, plug everything in. Do you know everything? So I can plug z in, correct? Because now we know the value of z. So I'm going to do it right here. So we have x equals -2 minus 2 times -3. PEMDAS, multiply first. -2 times -3 is what? 6. -2 plus 6 is 4. So x equals 4. Sorry, I forgot to write 6 right. All right, so we keep going. Now I have z and x. Can I solve for y? Yes. Which one is a good one to use to solve for y? 1. Doesn't really matter, right? But it's easier with 1 because it's just all of them have a coefficient of 1. All right, so we're going to plug in what we know to solve for y. X is what? 4. We don't know y. Z is what? And this equals -1. 4 minus 3 is what? 1. So we have 1 minus y equals -1. What is y? 2. Y is 2. I would have to subtract the 1 and divide by -1, which makes y equal to 2. So 7 is writing it as a solution set. So what is my solution set? 4, 2, and -3. It's always going to be x, y, and z. We've reached that point in the lesson where we've come to an end of the road. We have about, well, we can keep going. We're stuck in here. Silly people. Forgot about that. Where we going to go? Nowhere. We might as well finish our notes, right? All right. Guess whose turn it is? It's your turn. It's your turn to shine bright like a diamond and follow the steps. All right. You can work in your groups, talk to each other, ask each other, think out loud, talk to yourself, whichever you want to do. Yeah. Got it? All right. I gave y'all a challenge. What do you notice is different here?
None of them have no variable have two.
There you go. They don't have the coefficients aren't already the same for you, are they? We're gonna do it together to make the coefficients the same, and then I'm gonna let you fly, little birdies. Okay. So the coefficients aren't the same. Oh no, I quit, right? No, we do not. We do not quit. Okay. We decide on which variable is just the same, but this time you're gonna have to go back to your least common multiple. Do you remember that guy? LCM. Okay, least common multiple. So I always choose the smallest number so I can deal with the smallest least common multiple. Does that make sense? So in that case, what would be the better variable for us to eliminate? Y, because Y is 3, 2, and 1. And 3, 2, 1, what is their least common multiple? 6. The LCM of 3, 2, and 1 would be 6. LCM of 3, 2, 1 equals 6. So I'm going to change each one of these so they have a Y of a 6. Does that make sense? So I'm changing the Y's. How can I change 2 into a 6? Times 3. I'm going to have to multiply the entire thing by 3. Does that make sense? How am I going to change 3 into a 6? Times 2. And how am I going to change 1 into a 6? Times 6. Does that make sense? So we're actually working with, don't make fun of my brace because I can't draw them. Okay. I just can't. They never work. So 3 times 4 is 3 times -2 is going to give us our -6. 3 times 3 is going to give us our 9. And 3 times 1 gives us 3. We have 2x plus 6y minus 8z equals -7. And we have 18x plus 6y plus 12z equals 30. If you can do this, then you can do any problem with elimination. Does that make sense? That's why I gave it to you. All right. But do you see how we changed it so that we now have a variable to eliminate? Okay. And that variable that we're going to eliminate is, again, y. Oh no, it's supposed to be 14. You see nothing. What are you talking about? Nothing. That's at -14 all along. Yeah, I knew it. I knew it. It's okay. It's the weather. It's the weather. Is what's happening. Okay. All right. I'm gonna stop talking and let you go. Be great. All right. So really quick, here we go. So a lot of y'all did well on your own. I just want a little disclaimer. You didn't have to do the LCM in the beginning. I just like to do that because it saves time. However, it can create larger numbers for you to work with. And you just got to be willing to work with larger numbers. Okay. All right. So up first, they're in order. This is my equation 1, equation 2, equation 3. And I'm going to use equation 1 and 2 first to eliminate y. So that gives me 12x minus 6y plus 9z equals 3. And I have 2x plus 6y minus 8z equals -14. Eliminate, I'm left with 14x plus 1z equals -11. Okay. Next, I'm going to use equation 2 and equation 3 to eliminate y. So I'm going to use equation 2 and equation 3 to eliminate y. And that gives me 2x plus 6y minus 8z equals -14. And I get 18x plus 6y. I don't know why I did that. I was right at first. It was 1 and 3. I just was making sure that you guys were paying attention along with me. I'm at 1 and 3. So it's going to be 12x minus 6y plus, that is not even 3. Let me just erase this. Hello. Erase. Okay, sorry. back to what I was doing. 1. So we have 12x minus 6y plus 9z equals 3. And then we're going to do 18x plus 6y plus 12z equals 30. So this is going to be an example of if you do LCM in the beginning, this is an example of where you may get large numbers at. So we have 30x plus 21z equals 33. All right. Next step is to use substitution. So we're going to use substitution here. So I'm going to use substitution. I'm going to solve for z. So z equals negative 11 minus 14x. And I'm going to substitute that into here. So we have 30x plus 21 times negative 11 minus 14x equals 33. Okay. So again, we're going to do the trifecta. So we are going to distribute, combine, isolate. Distribute, combine, isolate. All right. So we have 30x plus, and then that's going to give us negative 231 minus 294x equals 33. We're going to combine like terms. So 294 minus. It's going to give us 264. So we have negative 231 minus 264x equals 33. And to get x by itself, we are adding 231 and dividing by negative 264. So we have 33 plus 231 divided by negative 264. And that gives us negative 1. So x equals negative 1. So we now know the value of x. So since I know the value of x, I can now go back and plug in for x. Pew pew, right there. So this leads me to z equals negative 11 minus 14 times negative 1, which is going to give me 3. So now we know that z equals 3. Now that I have x and z, I can go back to the original and choose one to solve for y. The one I'm going to choose to solve for y is going to be the third equation from the original problem because y can easily be isolated. Okay, so we have 3 times negative 1 plus y plus 2. Okay, equals 5. So we have negative 3 plus y plus 6 equals 5. Combine negative 3 and 6, and we get positive 3. So we have, so now we have y plus 3 equals 5. Subtract 3, and then we get y equals 2. So now our solution set would be negative 1, comma 2, comma 3, and bam. If you can do this, you can do all. All right, thank y'all. Please ignore the conversations in the background.